Hello and welcome to another math video. Today we are finishing out our FSTA final study guide, the final questions 56 to 63. We'll start here. We've got this diagram where lines M and N are parallel. We're given expressions for the measurements for angle A and angle B, and we need to figure out how to find the measures of those angles. So in this case, one key thing to look at is to make sure we understand the relationship between those angles. When these lines are parallel, there's really only two different angle relationships. They're either equal or they are supplementary. In this case, notice A and B are what we call alternate exterior angles. That means that they are congruent. Notice also that there's either obtuse angles like A and B or acute angles like what they're supplementary to. Those A and B both being obtuse angles, you can't really fake that even if it's not drawn to scale. Now whether they're obtuse or acute, that could be messed up depending on the diagram, but the fact that they are going to be equal, you can't really, again, fake that. So that tells us that we set 3x plus 59 equal to 5x minus 11. From there, we're just solving this equation. I would recommend subtracting 3x. I like to think of that first. So my x's are going to end up on the right, so I would like to then add the 11 to both sides. I get 70 equals 2x. So when I divide by 2, I find out that x is 35. Again, be careful. 35 is not the answer. 35 is what I use in order to find the answers, which will be the measure of those angles. The two equations are about the same. Maybe I'll just plug those into the 5 times 35 minus 11. So it'll be 175 minus 11, subtract the 11, 164. So they're both 164 degrees for that one. All right, moving on to number 57. The triangle on the inside, ECD, is congruent to BXA, kind of weird lettering there. I do find it helpful to label each thing with its value. So we're trying to find x. C is 6, D is 4, and E is 5. In this case, if you can't see this, that's fine, but hopefully you can see that D corresponds to A, and A is twice as big as D. So, and B is twice as big as E, so therefore x would have to be twice as big as the 6. If you don't see that, what I would recommend is setting up a proportion. So I would do, there's a few different ways you can do this. X over 8 equals 6 over 4 is one way to do that. Or maybe you do x over 6 equals 4 over 8. So there's different ways that can happen. Or actually, sorry, it'd be x over 6 equals 8 over 4. Hate to mix that up. So there's plenty of ways to do that right, but also plenty to do that wrong. Again, I do generally like to keep the values from the same shapes together, thus the x and the 8 being on the bigger triangle are together, the 6 and the 4 being on the smaller triangle are together. Some people like to cross multiply. I would just say multiply both sides of the equation by 8. That gives us x equals, and depending on how you want to figure this out, 6 times 8 is 48 divided by 4, well, so x is 12. And like I said, notice that's twice as big as the 6. So kind of easy numbers the way that one worked out, but that's how we would do that. All right, moving on to 58, dealing with some trigonometry. So theta is in an angle in standard position. The given point is on the terminal side of theta. Give the exact value that does indicated trig function for theta. So we're finding the cosine of theta. Now, one thing to realize too here is if we have an angle in standard position, let's see, 12, 16, so a little higher than it is to the right there. So 12, 16 would be somewhere there. Since this does go through the origin, again, it goes through the origin, we know that because it's in standard position. Then we realize actually the slope is 16 over 12, which reduces down to 4 over 3. So instead of going up 16 right 12, we could just go up 4 right 3, which would be somewhere around there, and that would actually get us up 4, so 3, 4. So 3, 4 is actually another point on that line, and so that's going to be a little bit easier to use. So I know x is 3, y is 4. Cosine, now again we got to remember our trig function ratios. Cosine is x over r. So I do need to find r. Remember x squared plus y squared equals r squared is kind of the x, y, r form of the Pythagorean theorem that we know better as a squared plus b squared equals c squared. In this case, since we're trying to find r, we would probably write that as r equals the square root of x squared plus y squared. In this case, we would square 3 and 4, and we get 9 and 16, so we get the square root of 25. So, and many of you I'm sure knew that already, but r is 5, and cosine being x over r would be 3 over 5 for that one. And again, I mean, if it helps, you can draw out those little right triangles there to see, oh yeah, hey, this side is really 3, this side is 4, well then that hypotenuse is 5. So that's why we're really dealing with those right triangles there. Let's see, number 59, same sort of idea, but instead of giving us a point to work with, they give us an equation and a condition for x. First thing I would do here is to rewrite the equation in slope-intercept form. It's just going to be easier to work with. And what I would like to do is pick an x value that satisfies this condition. So x has to be greater than or equal to 0. I want something that's going to work well, and 1 is the first number that works well when x is 1, y is 8. I want whole number or at least integer values for my x's and my y's. Now I need to find the sine. Sine of theta is y over r, so I need to find r being the square root of x squared plus y squared. So we add 1 and 64, we get the square root of 65. So sine ends up being 8 over the square root of 65. Now, that's a problem because I can't have the square root of 65 as my denominator. So really, we multiply numerator and denominator by the square root of 65. And then what happens there is we get 8 square roots of 65 over 65 as the actual answer. And again, we have to rationalize the denominator there. Number 60, we want to evaluate the sine of 450 degrees. You might be thinking to yourself, well, geez, how the heck am I supposed to do that? First of all, 450 is over 360. Oops, let me get my pen here. 450 is over 360. So let's see what 450 degrees really is. And we find out, oh, well, that's 90 degrees. Well, 90 degrees, simple enough because that's just straight up here. I just need a point that's on that terminal side. Well, the easiest point to use would be 0, 1. So x is 0, y is 1. R is also 1 because r is this distance from the origin to there. And sine still is y over r. So in this case, 1 over 1. So the sine of 450 degrees is 1. Cosine of negative 90. Well, that one's easy enough to figure. If you wanted to, you could do negative 90 plus 360. You figure out that's the same as 270. So negative 90 or 270 is going to be down this way. Again, we just need a point on there. So 0, negative 1, the easiest point to use there. So x is 0, y is negative 1. Now, r being a non-directional distance can't be negative, so it's just a positive 1. Cosine, though, is x over r. Again, notice the pause there. I still have to think about these things for a second. So cosine is x over r. Our x is 0. So oops, my letters are getting mixed up here. Cosine of negative 90. Again, I'll write it just the way it was presented to us. 0 over 1, so that's going to equal 0. And make sure that you do understand that's 0. Again, our final will be multiple choice, so I don't think 0 over 1 would be a choice, but they may have undefined certainly as a choice. Some things that would make sense for choices would be 0, 1, negative 1, and undefined. So very simple to cover all 4 of those options on a standard multiple choice test. That brings us to our final 2 questions, just determining whether the statement is possible or impossible for an angle theta. So really we're talking about do you know the ranges for the trig functions? The sine values, just like the cosine values, so I'm going to digress a little bit here. Sine values, I'm just going to put -1, 1, I'll just throw 0 in there as well. Sine values go from -1 to 1, just like the cosine values do. So it looks like that. That should have hit right there, but there we go. So sine goes from -1 to 1. Secant and cosecant go outside of -1 to 1. And there's no significance to me writing them above or below. It's just, got to go somewhere. And then tangent and cotangent can cover everything. So can the sine be 7.7? Well, no, because 7.7 is outside of -1 to 1. So this would be impossible. Okay, can't happen. And the tangent be -7.84? Well, yeah, that's possible. Tangent can be anything. So basically saying, yeah, there is some value for theta where tangent would be -7.84, whereas you could put anything in there for theta for number 62. No matter what you put in there, the sine is never going to equal 7.7. Well, as always, thank you for watching, and hopefully you found this video to be helpful.